Hi, welcome to the Sugar Math Fun Probability Problem Solving Sessions. And today we're going to take a look at this very interesting problems here. Okay, so the problem we're going to solve here is suppose x and y are non-negative discrete random variable with the following joint mass function. And this is kind of like, if you look at this function, this is kind of like the multinomial functions, right? So now in here, they want to calculate the marginal distributions of x and y. Okay, so like this one is, it's very, very similar like the binomial, but now it's a multinomial. We have like x, y, and 5 minus x minus y. Intuitively, if I want to find the marginal distribution of x, intuitively, it should be a binomial with n equal to 5 and p equal to 1/8. So the same thing is intuitively, when you look at these functions, y should be also is a binomial distributions with the n is 5 and p is 1/2. Right, because you just look at it by itself, and but how do we mathematically prove this? Okay, so now let's go ahead, go to our whiteboard, and then let's start to work on it. So in order to work on this problem, one of the main things we're going to use is the binomial expansions here. So let me write it down. The joint PDF is about x and y. So this is 5 factorial, x factorial, y factorial, 5 minus x minus y factorial. And then here, this is 1/8 to the x, and this is 1/2 to the y, and this is 3/8 to the 5 minus x minus y here. Like I mentioned before, the key things we're going to, the key formula we're going to use for solving this problem is the binomial expansion. So let me just write this formula here. So it's how do you expand a plus b to the nth power? So we know these ones here, you can write like this, from the k is equal to 0 to the n, right? And then you can have the n to the k, then the a to the k, and the b to the n minus k here. Okay, so remember, this is the key formula we want to use. Okay, so now let's take a look. How do I try to find the marginal distribution for x? So remember, if you want to find the marginal for x, you sum the y's, right? Just like if it's continuous, you integrate. So in here, I sum the y's here. So y is from 0 to what? Because in here, they give us the condition, they say x plus y is less than 5. So y is from 0 to where? To the 5 minus x here, okay? And then in here, we have 5. Now we have x factorial, we have y factorial, and we have 5 minus x minus y factorial. So this is 1/8 to the x, 1/2 to the y, and 3/8 to the 5 minus x minus y here. Okay, so okay, so for here, remember we want to use this binomial expansion. So I'm going to manipulate this one a little bit. First, I'm going to move everything so has no y. I'm moving outside. I'm going to move outside this summation signs here. Okay. So now let's take a look here. So first things, I move the 1/8 to the x to the out, and then I have this is x factorial. Okay, so now this is y equal to 0 to the 5 minus x. So here I have y factorial. I have 5 minus x minus y factorial. So in order to match, so maybe I will write out this one here. This is a summation k from 0 to infinity. So this is n factorial, k factorial, n minus k factorial, ak, and b the n minus k, right? Okay, so now in here, I try to match this formula. So this is like, so take a look, this is kind of like your what? Kind of like your k factorial, right? And what is this one here? This is kind of like your n minus k factorial. So my n, what is my n's here? My n's will be what? Will be 5 minus, so this will be 5 minus x factorial, right? Okay, so here also, okay, so a while ago, because for 5 factorial is not to the x, so I can move the 5 factorials out here. And now I'm manipulate this. I know I cannot just add some term like 5 minus x factorial. So what I need to do here, I need to divide the 5 minus x to the factorials here. Okay, and now in here, so this is 5 minus x, then here this is 1/2 y, and this is 3/8 5 minus x minus y. So compared to my expansion, the binomial expansion formula, so you can treat this is like what? This is your a, this is your b's, right? And 5 minus x is your n, and then this is your k minus k. So what happens here? So the whole thing here, if you use the binomial expansion, so okay, so let's rewrite this. So these are the constants: 5 minus 5 factorial, x factorial, 5 minus x factorial, right? So this is 1/8 to the x. Okay, so remember, right? So this is the binomial expansion. So what is this one going to become? 2a plus b. So it's 1/2 plus 3/8. A plus b to the what? The nth power, right? So a plus b to the nth power. So this is a what power? 5 minus x power. Okay, so 1/2 plus 3 is a what? Is 7/8 to the 5 minus x. And wow, so what is here? This is what? This is the binomial with what? With n equal to what? N equal to 5 and p equal to what? 1/8. Right, so you just manipulate your term, then use the binomial expansion formula, and you can find this. All right, so let's do the same thing. That the y will be exactly the same. So if you want to find the marginal of the y, you sum up the x. So it's x is from 5 to x0 to 5 minus y. Then this is a 5 factorial, x factorial, y factorial, 5 minus x minus y factorial. Then this is 1/8 to the x, 1/2 to the y, and 3/8 to the 5 minus x minus y. So the same thing, let's put everything has nothing to do with x. Take that out, this one's and this one's, right? Okay, so now let's take this one out. This will be 5 factorial, y factorial, and then this is 1/y, 1/2 to the y's power. Okay, now here, this is summation. X is from 0 to 5 minus y. So I have x factorial. Then I have 5 minus x minus y factorial. Then here, this is 1/8. and then this is 3 over 8 to the 5 minus x minus 1. Now I'm using the same trick here. I want to match the binomial expansion. So I need to have a 5 minus what? I need to have a 5 minus y factorials here. And I cannot just add 5 1 minus y. So what I need to do here, I need to divide by the 5 minus y factorials here. Okay, so now here is exactly the same. So this will be your A, this your B's here. So these things here, by using the binomial expansion, so what will be? So will be 1 over A plus 3 over A to the what? 5 minus what? 5 minus Y, right? So this is become what? 1/2 the 5 minus y. So now you put these ones here. So this one is here 5 factorial y factorial 5 minus y factorial 1/2 of the y, right? 1/2 of the y here. So here 1/2 of the y, and we just did the binomial expansion, so it's 1/2 of the 5 minus y. Wow, what is this? This is the binomial again with n equal to 5, and what is your p? P is equal to 1/2. All right, so this is match what our intuitive feeling about this PDF, right? Because when we look at the joint PDF, so we know this is a multinomial distribution. So if you want to look at the x, it's kind of like just be x and something else. So it's kind of intuitive, you know it's a binomial. And then this is how do we prove it. Okay, so basically you just try to manipulate the expression and try to use the the binomial expansions here. This is a very, very important formula, the binomial expansions here. All right, that's it. And if you like the way I solve the problem, feel free to subscribe to my channels here. All right, and I'll talk to you to take a look what is our next fun problem we'll be able to solve together. Okay, talk to you later. Okay, bye-bye. Have a good day.